P/F, that field reference to the pole/final bit. The pole is being given by the primary station. When the primary sends a command, it is called as the polling. And when the secondary responds to that particular pole, it is called as the final bit. So when it sends a response, it set the final bit to 1. And this yes represents the supervisory function bits. We have some plenty of bits, code words, and supervisory commands equivalent to it. Likewise, in unnumbered frame, this M represents the unnumbered function bits. We have some set of function code words and its functions. We'll see that one by one. First, what about the pole and the final bit? As I've already told, the primary and secondary in an unbalanced configuration scenario, when the primary issues a command, it will set the pole bit, and when a secondary responds to that particular pole bit, then it will set a final bit and send that frame. So otherwise, the secondary cannot initiate any transmission without a pole frame. That is the usage of it. The pole command, it is used for pole from the primary, and the F is response frame. Coming to the iframe, we just saw this contains the informations. N of S represents the send sequence number, and N of R represents the receive sequence number. Some sample iframe values include I comma 0 comma 0, and then this I comma 2 comma 0 comma P, which means it is a pole frame. Then S frame. Yes, it helps in the flow and the error control strategies. Example includes it has four particular commands: the RR, RNR, and the reject. The receive not ready, reject on frame, and selective reject on frame. These are the four supervisory bit options available. And then coming to the unnumbered frame, it takes care of the mode setting, recovery, connect, and disconnect options. And all these things will be set in this particular position. And the starting of the frame will be 1 1. These are some of the commands which the unnumbered frame contains. First thing is when you are setting the mode, so it can be a normal response mode or asynchronous response mode or asynchronous balance mode. Apart from that, we have disconnect function and then test function, frame reject. So all these things can be included in the unnumbered frames. And then coming back to the frame structure, the next field after the control field is the information field. This contains the actual data which is to be transmitted. So it is obviously a variable length field, and it contains integral number of octets. The next field is the frame check sequence or the FCS field. We all know this field is particularly used for the error detection scenario, and this includes a 16-bit CRC. So that helps the receiver to identify whether any bits are being changed or not. And then HDLC operation, we have seen all the modes and the frames. So what about the operation? It includes three phases: initialization, data transfer, and disconnect. In the initialization phase, the mode will be set, the link will be established, and then the frame transmission will happen. And finally, after transmission, the link will be disconnected. This is an example scenario of how the link setup is happening, and then the two-way data exchange and the busy condition. First, about the link setup and disconnect. So it includes the series of steps. The first one is SABME, which means set asynchronous balanced mode. So it is sending the station A is sending this request. And after some time also it didn't get any acknowledgement. So that's why after the timer expires